right, so here's problem number 3 from section 7.3. All right, and so we've got a solid, and planes that lies between planes perpendicular to the x-axis. Cross sections perpendicular to the axis are squares whose diagonals run from y equals negative square root x and y is equal to positive square root x. So there's the two curves that we're running in between. These things are running perpendicular to that axis. And of course, when I draw that red line, what I want you to imagine is that's a square that's coming out of the board at you. If I take that square that's coming out at you and I press it down, it would look like that. And of course, that's just one of an infinite number of squares that represent those slices of that solid. Yeah?
It says the diagonals run from there to there, not the edge.
Oh, okay. So instead of that, you're saying what we have is, well, hold on. I need a piece of paper that is, okay, this isn't going to show up on the recording, but here's a square, and really what's going on is half of the square, and it's running like that, out of the board. Okay, so if I were to try to draw that, the square would look like this. Whoops. If I pressed it down and brought the other end at the other side.
That's weird. It's a round. You're making
It's a what?
a triangle that's flat.
It's like, here's this, and it's just like a graph.
One of those triangles was pointing out of the board. The other was pointing back through the board, and it was actually in Mr. Zurid's room. You're okay?
Yeah.
All right. So when that square was in its original position, how would I grab it? Would I grab it in a dx orientation or a dy orientation?
Looks like dx.
Dx. So I write down dx because that's going to guide a lot of my work. Everything I write now has to be in terms of x. I start by saying, hey, for some arbitrary x, what do I have? Well, I have this location here, which would be x comma root x. I have this coordinate here, which is x comma negative root x. All right? And I'm looking for a formula for the area of a square found at an arbitrary location x. Let's see. What do I know about squares? I know that squares, if they have sides 1 and 1, they have a diagonal, which is root 2. Now, that's great if you have a side length and you want to know the diagonal. But in this case, what I really have is that I know that this diagonal is 2 root x. And what I want to know is, what's the side length? Well, if I divide each of these numbers by root 2, I would find that when the diagonal is 1, I can find the length of the side by dividing that 1 by root 2. Or in this case, if I know that the side length or the diagonal length is 2 root x, I can find its side. So let me write that down. If the diagonal is 2 root x, that means the side will be 2 root x divided by root 2. And again, this is geometry coming back to haunt you. I am the ghost. All right. So how do we transform this side length into an area? I think we square it. So there's our cross-sectional area there. There's our little bit of thickness. So this is a representation of one little piece of volume. And of course, we want to add up all those volumes from 0 to the largest value that x takes on. which is 4. And I believe that integral expression then represents the volume of that solid. Now all that's left is to evaluate it. Let's see, let's square that integrand. And I get 4x over 2, which simplifies nicely to 2x. Boy, could you be happier? What a nice integrand to solve.
X squared.
X squared as evaluated from 0 to 4. Looks to me like the answer is 16. 16 units cubed if you're getting hassled by Mr. Meacham.
I'm still confused when we get 2 root x over root 2.
Okay. Are you okay with the idea that if we know the diagonal, we can find the length of the sides by dividing by root 2?
Oh, okay.
Similar. Yeah. They're similar squares.
And the
Okay.
the length of diagonal is 2
Right. Or I could say, if I multiply by root 2 to find the diagonal, I must have to divide by root 2 to find the side.
Root 2 is to 1 as. Okay.
Well, I mean,
Scratch that.
1 is to root 2 as 1 over root 2 is to 1. Is that okay? All right, so again, geometry. By the way, does that have the happy convenience of actually being the right answer?
According to the light
According to the light blue writing.
Oh, it's right there. Yep.
Check box. Use graph paper.
Okay, very good. Let's close off that recording.